Hello, people. So it is now May 2024, and I've been using the benchmark operator for 4 years, and I still get a lot of feedback that it is very hard for people to start using a benchmark operator. And from the feedback I got so far, it mostly is about the Elasticsearch. So today, I wanted to just show you how I installed the benchmark operator with no external dependencies, how quickly you can do it, and how quickly you can make use of this based on an example with Theo. I'll try to add a link down below the video with a gist so you can follow along with the most complicated commands that I execute, and also in the end with the Kibana dashboard. You'll find a link to that down below. So first, the benchmark operator is provided by the Red Hat Perf and Scale team. I'm not a main contributor. I'm just someone who uses it a lot and has contributed a couple of PRs over time, every now and then. It's perfect because it actually is not that hard to install. It runs natively in OpenShift, and it can show you exactly how your workload is performing on the storage. And for that, it supports a staggering amount of different workloads. So today we will focus on Theo because that's the most common use case for me, at least. But what you see here um, works for most others as well that use Elasticsearch to send um, the results, right? So we will just start, and I have here my VS Code. It is connected to my cluster. We can check this here. It's connected. We're on the default project and a server here. We do have different storage classes available here. So I already installed ODF, of course. This is running on top of VMware. So we do have the thin storage class installed. Um, Now, obviously, it's acting up a little bit. So this command is taking longer than it should. And yeah, what did I want to say? Oh, unlock login. Let's try that again. Yeah, now it works. Very nice. So as you can see, we have ODF installed here. We don't have any Elasticsearch or anything in the default project right now. And we don't have the benchmark operator installed either. I am in a repository, so I already cloned it. I did the change 0 there. So let's start and do this make deploy. So we got the benchmark operator installed. Let me make this a lot larger. It's easier to follow along. I'm telling you guys, this was super fast before I started recording this video, but I didn't want to like speed this up artificially because I want to show you how long it takes to get this all set up. So it's now doing its thing. Now we technically we have the benchmark operator installed in the benchmark operator project. We can go in there. Project. Oh, come on. Benchmark operator. There. And in there we should see like the deployment and the pods starting up and all of that. Now what we need is we need Elasticsearch because we want to send the information about our performance test to Elasticsearch so we can visualize it, right? So while this is doing its thing, let me already show you this. So Elasticsearch has this Quickstart on OpenShift. So Quickstart for the ECK stack, so Elasticsearch and Kibana. That's what we're after. And basically, it's just copy and paste for us. So we deploy the operator. It's these two URLs that just get deployed in your cluster. Let's see how long that will take. Now, the next step is optional. So it's doing this. Next step is optional. We don't need that for a default OpenShift deployment. And now, since I am using kubeadmin, I don't need a third step either because we don't need to. I need this, but I don't need the permissions later. So we create this new project, Elastic. Issuing that command will automatically create a project and switch into it. So let's wait for the operator deployment to finish. So one life advice, don't try to record how easy and fast this is because that's a bad idea. Okay, so now let's do this new project. Again, all right. We're now in this Elastic project. We don't need the policy because we're kubeadmin. And now we continue. And now we have the operator. And just like with ODF, where we then create a storage cluster, here we are creating Elasticsearch. And that will actually deploy the Elasticsearch. Now, it's important that I switch into this new project because this YAML doesn't mention any namespaces, so it will deploy in any namespace that you are in or in Elastic here. So we just copy this. Okay, got confused. All right, let's try that again. Bam, finished. And now all we have to do is deploy the Kibana instance. Kibana is like Grafana for Elasticsearch, so just the front end. Now, one thing here is they have a little bug here where the API version is v1. My OpenShift will not allow this because obviously it can't be v1. You will see that here. So if I just try this, it says, what is this v1 you're talking about? So already open a PR to fix this. So potentially when you are watching this video, this might already be fixed. Just showing you I'm fixing it here. And now this looks like this. The only thing I changed is this API version to route OpenShift IO v1. a completely different thing. And now it should get it. All right. So now we are in this Elastic namespace project, whatever you want to call it, and we have two routes. One route that leads to our Elasticsearch, and one route that leads to our Kibana. So we can go to Kibana now, and we can go to my Kibana now. And first it will complain about the certificate. That's fine. It's a self-signed certificate. Right? And the first thing it will do, it will say, oh, hello, I don't know you, please log in. Now, the username is always Elastic in this case, and the password is always randomly generated. And this is where it gets funny because you need a very special secret here. And this is the magic one-liner to read out the password for your Elastic user. So we just use that. Paste. Now that lets us in. I don't need that anymore. Now we're logged into Kibana. We know our user and the password for Elasticsearch. We know the route. And now the problem is when you go to discover, where we would see our data, there's no data. Add your data to get started, right? So now we are supposed to add our data. Now, how we do that is we deploy a workload. Now, I said we will do the example with field, but that will work with pretty much anyone. We have an example field CR here, so we will base our work on this. So right now it looks like this. You see that in config samples field CR YAML. So let's work over here and use that. So we are in here. So in config samples VOCR, that's what is linked in the GitHub repo as your example. So let's start from the top. We have our benchmark kind. We have here all the information about our run, the name, the namespace, and now we're going to Elasticsearch. Now we need the route for Elasticsearch. We want to reach Elasticsearch, so we take this one. It's HTTPS, and since it's self-signed, it's very, very important that that we set verify cert to false. Now this needs to be authenticated, so we want to authenticate as the user Elastic, and we want to authenticate using our password down here. So let's do that. So the syntax is username, colon, password, at, and then the URL. That's what you use. And then verify cert false because self-signed certificate with HTTPS, and now you're golden. This should work to send your perf results to the server. So we want to do a very, very quick run just to verify that everything works. We want to do 3 servers, 3 samples, that's fine. We don't want to pin to any node. We want to do just one. Well, we can do a couple of jobs. We want to only do 64K block size. We want one num job, IODEF 4. Well, we could use 32. That's fine. We want to do 2 gigs of file size, and log sample rate where we see the performance. We leave that all default. And now let's do that. So now we go into our benchmark operator project. This is where our operator is and nothing else. So now what we'll do is I save this file and now I do OC apply and this is in config samples cr.yaml and that will create a benchmark. Now a benchmark, we can watch this. That's what I recommend. So we watch OC get benchmark pod and PVC. That's what I usually do when I run a benchmark. Now what you'll see is up here is our benchmark and it has a state. That's what it's currently doing. Now it's running. So it started 3 servers that are actually doing our IO and 1 client. And now the running state means it's actually doing the benchmark operation. This could also be prefill if we kept this true. Now it's just running through the field test. If we are curious and we are in a temper to see exactly what's happening, we could also watch the logs from one of the pods so that keep forgetting to copy what I select. And here we would see from the client side what it's receiving from the service. And here we would see like the results. So now we have 3 samples. So we do 3 write operations and then it's done and sends it to Elasticsearch. And then we would see 3 times read and collect the information and send it to Elasticsearch and then run write and run read. So that will take some time, but we would see any Elasticsearch errors here on the client as well, and we see exactly like we're sending this to and what it's doing with Elasticsearch. And here we see it connected to Elasticsearch and it's outputting the information down here. So you know, this connection actually worked very well. And now let's go and see here Kibana again. Now it had this add your data to get started. Let's refresh this, go to this cover again, click refresh. One thing I should probably mention is when you deploy this Elasticsearch cluster with Kibana, with its default settings from the Quickstart, it is not backed by any data. So if your nodes reboot, then you're losing that Elasticsearch data. For most of my workloads and tests, this is totally fine because I just want to like get some information out. Okay, so now we have data in Elasticsearch. It's quite happy. It's a fantastic icon. We can't use it right now. We need to create a data view, but this is quite easy. We give it a nice name like Ripsaw, and then you see here we have some index patterns, and now we just need to find a nice name that matches all of them. We select date as a timestamp field. And that's it. Now we're ready to look at our data. Now, the next thing is the perf and scale team. They have a long-running Elasticsearch cluster, and they've made a lot of effort to create fancy dashboards. And I'm sure once upon a time they are ready to share these with us. But it's actually quite easy to look at the field results as well. So we're interested in IOPS, we're interested in latency, and maybe we're also interested in the bandwidth. So we have these as key fields. here in Elasticsearch. And let me show you how that works. So for example, let's start with IOPS. And we click on this, and now it says, oh, IOPS, and you see like the top values written out. That's not too helpful, but we can click on Visualize, and that will allow us to start a panel. Let's call panel. So by default, it's not very useful because it's trying um, to show us this like this. Now it's like the medium of IOPS of everything. Now that's not too interesting. And this is the date per 30 seconds. That's already good. So with horizontal axis set to date, if it's not set to date, set it to date, date histogram, date. And now here you can decide. You want median, you want max, you want average. I think medium or average for IOPS is quite a good idea. I'll just set it to average for now. And now we want to break it down based on the job name, because the job name will say, hey, is this a read, run, write, whatever? What kind of job is this? And sometimes it breaks a little bit. I don't know why. But yeah, let me just click on the thing, a couple of things. Maybe it starts working again. Maybe it's because we haven't received more than one job name yet. So we can close that for now and try that again in a second. Um, this is a stack diagram. We don't necessarily want a stack diagram. We want usually bar vertical, so we have the bars next to each other. Once the job name thing works. So what we wanted to see here is when we go back to Discover and look at the data, um, we wanted to look at the job name, and okay, it hasn't received anything here yet. We wanted to see read, write, run, write, etc. here. And for IOPS, we wanted to see IOPS too. Here we have IOPS. So some outputs from the resolve field wouldn't produce IOPS, so maybe they would produce latency, or maybe they would produce the bandwidth. So you can see this. So here we have IOPS, there we have bandwidth, here we have latency, and we get other information about the run, like the cluster name. We can set that in the CR as well. Field version or the options, how this benchmark was set up, like job name. Here, job. Oh, I see job name. Let's go back. Obviously, my fault for using job name. Different keyword, better results. So now it's the way I wanted it. And now we see these beautiful colors for the different job names, and we can see, okay, these are the IOPS for read, these are the IOPS for ren write, and here we have ren read, right? So now we have the different colors, and we have average of IOPS, and this is a nice panel or chart, depends on who you are, and we want to add this to dashboard. So we click on save, and we say title is average IOPS Repsol Theo, whatever, and we add this to dashboard, a new dashboard. Now we have a new dashboard, and we can say, all right, I not only want to look at average IOPS, I also want to look at the average latency, for example. Latency, right? So let's do that. We go in, we say edit visualization. We're in here again. So you see, again, bar vertical. We're based on Ripsaw. We horizontally, we have the date, and vertically, average of IOPS. We want to change that to latency. We have all these fields, but we are not interested in that. We just want latency. Boom. Now, if you want to get extra fancy, we can also tell Kibana what kind of value this is. We can say this is a duration, and this is nanoseconds, and we want to have these precise. And now we can see, okay, this this goes up pretty far here, and it's trying to convert that to a human-friendly format for us so we can more easily read that. We can compact the values so it doesn't say milliseconds, it say ms, which gives us more space for the actual content here. And this is perfect. Maybe change the name again. Remove the copy. Much better. Now, what's missing? The bandwidth, right? So let's add the bandwidth. Average bandwidth. I think that's right. Let's do that and make it so. So average bandwidth. This is not a duration, but these are bytes. And now close this, and we see pretty much the same thing here. Now, what's interesting for us too is not just looking at the averages, but maybe we also want to see the max latency. So let's do that. We go in edit visualization, and we say, okay, we have average here, and let's do here latency again. And this time we select maximum of latency. That's good. This is again a duration of nanoseconds, and we want to keep that precise and compact. All right, back. Now, when we look at this, it's not too pretty, right? It gets very tiny. We can't really see with the max compared to the average. We can hover it and we see like that the spread is pretty far, but it's not very human friendly to look at this. So maybe it's about time to change the visualization, and we can do it here. So instead of bars, I would recommend we use lines, and then immediately we see, okay, here's the max, and here's the average. Okay, that's much better. We can zoom in here, so we can select this time range, and then it's easier to see in all charts. And then we see the spread of average and max, and we could now also add mins the same way. Um, Now, one thing that I usually like to do is I like to add a control. That means that I can select my different test runs based on the UUID. So the UUID, let's go over to the benchmark again here. Remember how we had this benchmark here, and this is now complete. So it ran all the tests, and this has a UUID, right? So if we are fancy, and I am usually too lazy, we could change the cluster name or the test user and make that one of our controls. But I'm usually too lazy, and then I can differentiate the different test runs based on the UUID. So we have that here. Right now, we only have that one run. Now, one thing I wanted to show you here is we were kind of stupid. Now, I made that on purpose because I want to lead you into a trap. And you can see we have, we're running this OC-get benchmark, pod, and PVC. And we see the benchmark, we see the pods that are created, and the pods will stay around until we delete the benchmark. But we don't see any PVCs. So we're not actually using any storage. This is just using the ephemeral storage inside of the pod, which makes no sense, right? We want to test actual storage. So we go back, we go to our storage classes, and now we see, okay, here we want to use the RBD storage class. We want to benchmark ODF. And we go in our CR and we say, oh, storage class. There you go. Please copy this, put it in here. And we set the storage size to 5 gig. It needs to be larger than the file size of Theo, right? Because then we have the space required. Let's save this, and I don't want to wait that long, so we will only do one run write test with 3 samples, and then we can average over the samples. The benchmark operator will do the sampling over the for us. So what we're seeing is actually a sample over 3 tests, so it's very reliable. All right, and now we instead of apply, we will do delete. That will clean up the benchmark and its pods, and we can start the next benchmark immediately because it will get a different UUID, and that will be fine. Now let's watch this again. We'll see, okay, it's building this, it's starting Theo servers, and no, it's terminating these, but now it immediately created the PVCs with 5 gigs as we expected, and it's now creating new Theo servers for our new benchmark. Starting servers, servers are now running. Now it's starting the client. There it is. The client will start the field test on the servers and collect the result. And we should see that immediately in Kibana. So let's head over here, make that larger, select last 1 minute, whatever, 15. In the meantime, I can save my dashboard. I call that Ripsaw Theo. And now we wait while this is running the benchmark. And it's complete. That was real time. I didn't speed anything up. Um, and I'll click on refresh here in Kibana, and we should see the new results. There they are. And you can zoom in if you want to. We see the different measurement points here and there. And now we want to compare these with like the last 30 minutes. We could add a control here if you want for the job name, obviously underscore. And now we could say, okay, we only want to run right results, so we can compare this. So these were the first results from the different UUID that were just in the pod in ephemeral space. Obviously, much higher IOPS than with ODF, and much lower latency than with ODF, and also higher bandwidth than with ODF. Makes sense, but it's ephemeral. We don't want to look at this now. But this way, you can easily compare this and that and see that which one is better or worse, and also get out your measurement values for all the three different things. Now, this is all that I wanted to show you today. I will, as I said before, I will add the most important commands and links in the video description. And also in the gist, you will find the export of this dashboard. If you're in Kibana, you can go to stack management, and then in saved objects. And here you can click on import and import the dashboard that you found there. It's an ND-JSON thing. And that way you get your dashboard. You don't need to click through Kibana like I did for you. And yeah, keep exploring the benchmark operator. It's a very nice tool to benchmark your storage clusters.